Now, how to classify these hydrocarbons? There are various probabilities in this type of hydrocarbon. Let us go one by one. Number one, there is chance that it may be open chain or closed chain. Closed chain we are calling as cyclic compound. Let us check. See, this is carbon, this is carbon, this is carbon, like that. N number of carbon atoms are there. But this end of chain and this end of chain, they are free. Then we are calling that as open chain compound. Whereas sometime it may be there that this is carbon, this is carbon. So like that, carbon can form this type of closed compound. That we should not say there is start of chain and there is end of chain. So this way compounds are there, we are calling that as closed chain compound, or they are called as cyclic compound. Keep in mind now, remaining all valencies are satisfied by hydrogen. Carbon is tetravalent in nature. And so there are two types of compound possible, that is carbon, hydrocarbon, that is as open chain hydrocarbon and closed chain. Then again, in open chain, there is chance that there should be one double bond, may be possible, that is between carbon and carbon, may be possible, there are two double bond between carbon and carbon, may be possible, there is one triple bond between carbon and carbon. Same way here also, there may be double bond between carbon and carbon. So like that possibilities are there. On basis of that, we are classifying compounds, that whether compound is open chain or closed chain. Then presence of double bond is there, triple bond is there, like that. So first, we are focusing on only open chain compound. So here, I should draw tree diagram that will indicate the compounds. So hydrocarbon, it is divided into basically two parts, that is open chain compound and closed chain compound, or we can consider that as cyclic compound also. Now in case of open chain compound, I am taking here broad sense, that as first we are focusing on open chain. So open chain, we are calling one compound category as saturated compound, another category that is as unsaturated compounds. So we have clear-cut idea now that hydrocarbon divided into open chain and closed chain. Out of that open chain compound, we are dividing it into saturated compound and unsaturated compound. Now what is saturated compound? That all bonds are single bond. Then we are calling that as saturated compound. Unsaturated compound, at least one bond is double bond or triple bond. Getting idea? So if at all any one double bond is present or any one triple bond is present, then also we are calling that as unsaturated. At least means what? Minimum. May be possible unsaturated compound may contain two double bond, three double bond, one triple bond, like that, anything. But minimum one double bond is present or triple bond is present, we are calling that compound as unsaturated compound. Now, in case of saturated compound, we have only one variety. Here I am showing. This is called as alkane. See, this is called as alkane. Now, in case of nomenclature, this ANE is important over here. So we can go here by alkane. So I am writing here ANE, that is in underlined form. It is having general formula. Now in order to make it generalized, we are considering certain formulae. On basis of that we can calculate. Let us check out. It is having general formula as CN H 2n plus 2. So make here bracket. Let me clarify. Here say C, N. So I can put any number over here. Let me put here number 4. So if carbon 4 is there, what is number of hydrogen? That is H, 2 into 4 plus 2. Now you are aware when this type of thing is there, first we have to carry out multiplication and then addition. So 2 into 4, 8, 8 plus 2, 10. So it should be C4H10. So we can calculate number of carbon and number of hydrogen with this type of formula. We are calling that as general formula. Let me draw the structure also. We have 4 carbon, satisfied valency with hydrogen. Let us check out 1, 2, 3, 4. So 4 carbon, satisfied valency with hydrogen. So first hydrogen, second, third, fourth, fifth, 6, 7, 8, 9 and 10th. So this way carbon 4, hydrogen 10. This is general formula for alkane. Now this type of variety is there. We can check out any carbon. Say carbon 10, the number of hydrogen. So here C10, I should write here C10. Hydrogen should be 10 into 2, that is 20 plus 2, that is 22. So hydrogen number should be 22. So like that series of carbon is there, we are calling that as alkane. Now I want to name here few alkanes. Few means 10 alkane I have to name. So carbon 1 is there. Here I am writing number of carbons. So number of carbon and name. So if 1 carbon is there, we are calling methane. Say as it is alkane, the nature that ending with ane, I should call as N. So this is methane if carbon number is 1. If carbon number is 2, it is called as ethane. Now many times there is confusion between pronunciation methane and ethane. Here spelling is also same, but what is ending with ane? Everywhere you will get this type of name. Third, that is propane. Carbon number 4, butane. 5, pentane. 6, hexane. 7. Now if you observe our history lecture, we are calling that as the pronunciation problem between s and h, and similarity between Sanskrit language and other European languages. So here we are having somewhat similarity here, because in Sanskrit this 7, that word is sapta. So here also word is going with the way same, but instead of s I have to pronounce h. So spelling heptane. So instead of sapta we are pronouncing hept. Now 8, Sanskrit word is ashta. Here somewhat similar pronunciation, octane. Sanskrit 9, that is navama. So here it is 9. Then nonen. And if it is 10, Sanskrit word is dashama, similar word deccan. So this type of 10 alkane you have to write and by heart. I hope there must be pen in your hand and you are writing out these all names. If not, then pause this video, take it back and write down all the name. No doubt they are there in book, but once writing is really important, then you have to by heart, because these are very basic names. Again and again we require that. So getting idea. So let us revise. Carbon number 1 methane, carbon 2 ethane, carbon 3 propane, carbon 4 butane, carbon 5 pentane. Sanskrit word is pancha, so similar pentane. carbon 6 hexane, carbon 7 heptane, carbon 8 octane, carbon 9 nonane, and carbon 10 decane. So this type of alkanes, 10 alkanes you have to by heart, then organic chemistry is easy, somewhat, because rest of the things also we have to by heart to larger extent. Now, in case of alkane, we are having certain chemical properties that we are calling as in gradation. So a simple thing is there. Compound is made up of only two elements, that is carbon and hydrogen. Electronegativity is same. So all chemical properties predominantly depend upon molecular weight. Particularly physical properties are depending upon molecular weight of the substance. When all elements are same, so between CH4, that is carbon, and C2H6, that is CH4, that is methane, and C2H4, that is ethane, we are having same set of element, that is carbon and hydrogen only. So properties are depending upon molecular weight. As molecular weight increases, melting point and boiling point increases. In this respect, keep in mind, if different elements are there, then it is not necessary that it should be there. But when same set of elements are there, bonding nature is same, then this is not possible. That other properties are not getting interference. It depends predominantly by molecular weight. So methane is having very low melting and boiling point because its molecular weight is very, very less. Whereas ethane is heavy molecule. 2 carbons are present. So net double the weight. And that's why we are getting increasing of melting point and boiling point. Propane, still more melting and boiling point. Like that. So at room temperature, methane is in gaseous state. Ethane is also in gaseous state. Propane is also in gaseous state at room temperature. Whereas butane is also at gaseous stage. But if you apply little bit pressure, it is converted into liquid. So it is at room temperature, at normal pressure, that is 1 atmospheric pressure, it is at room temperature and 1 atmospheric pressure at gaseous state. But if you apply little bit pressure more, then it is converted into liquid. And this is the fraction of petrochemical which is famous as LPG, that is liquefied petroleum gas. Liquefied petroleum gas is mixture of butane and isobutane. Now what is isobutane we will discuss later, but here we can basically discussing alkane part. There we are discussing out that mixture of butane and isobutane, that is called as LPG, liquefied petroleum gas. Now these alkanes are not having odor, that means smell is not there for any alkane. They are tasteless and having no smell. But you must have noticed that in case of LPG there is smell. I was also having similar question in my mind, that while teaching in our school, teacher used to teach this way, that alkanes are having no odor. Smell is not there for alkane. But butane and mixture of isobutane, that is called as LPG, that is liquefied petroleum gas, which is we are using for our domestic purpose gas. So that is having smell. So some explanation is there that certain compounds are added in the LPG so that the gas leakage can be detected, because as there is no odor, we are not supposed to detect gas leakage. In order to detect that leakage, we are adding out certain compounds in LPG so that one can detect gas leakage by smell. Getting idea? So predominantly LPG, suppose is there, it should not have any odor. But in order to detect leakage, we are adding some compound, and then that leakage we can detect by just smell, if you are having sense of smell then. Why? Because many people are not having that smell that sense of smell. But that's why some intense smell making chemical is added. What is your part? As you are using internet and various books also, you are referring out, I am aware. So what is that? Your role, that you have to find name of compound which is giving order to LPG. Alright, so find out that name and give it me in comment. Let us check further. Then pentane, at room temperature it is in gaseous state only. But next member, that is hexane, is having very low, it is there at liquid state with very low boiling point, supposed to be, when particularly boiling point of substance is less than 100 degrees Celsius, that is less than boiling point of water, we are calling that compound as volatile compound. So pentane, hexane, heptane, octane, all these compounds are volatile liquid. What is the meaning of volatile liquid? That it is having considerably low boiling point and therefore it is evaporating at very, very low temperature. So suppose there is a petri dish and you are taking out octane, then it will evaporate faster than water, because ultimately rate of evaporation is depending upon boiling point. The boiling point is higher, rate of evaporation is lower. So suppose in one petri dish you are keeping water and in another petri dish you are keeping oil, say coconut oil. The coconut oil being higher boiling point will evaporate slowly, whereas water being lower boiling point than coconut oil evaporate fast. But if you are keeping ethyl alcohol, organic compound, will go to that how it is there, etc., etc. It is having boiling point somewhat 678 degrees Celsius, whereas water is having boiling point 100 degrees Celsius. So same quantity of ethyl alcohol and same quantity of water you are keeping, then ethyl alcohol will evaporate fast than water. But suppose acetone is there, that is nail paint remover we are using. So that nail paint remover, suppose same quantity of nail paint remover, that is acetone, and same quantity of ethyl alcohol, that is spirit. Surgical spirit we are using, that before injection doctor is applying on skin, that spirit suppose we are keeping, then acetone will evaporate first as its boiling point is 56 degrees Celsius, and then ethyl alcohol will evaporate. Getting idea? So here the volatile substance, that means boiling point is less than 100 degrees Celsius. The mixture of hexane, heptane and octane, I am revising, mixture of hexane, heptane and octane is called as petrol. So whatever petrol we are using, that is mixture of hexane, heptane and octane. And that's why you are aware that in engine there is a part that is called as carburetor. Before that engine, in a vehicle, that carburetor which mix out petrol and air, where petrol is in gaseous form. Why? Because it is volatile, so it converted into gaseous form easily. So that's why we are having concept that volatile liquid. Like that, as carbon number increases, melting point and boiling point increases, and that's why compounds appear to be in liquid state. For carbon number 20, the compound appear in solid state. You are aware of candle wax. White colored candle wax is there, that is obtained from petrol, that is having boiling point very high, and so melting point is very high, and so it is obtained in form of solid state. So this is particularly about physical property, that is we are discussing for alkane, and general idea that alkanes in our daily use that we discussed over here. So predominantly even petrol is not having smell. Why? Because it is alkane, but we are adding out some sort of color in petrol. We are adding some sort of smell, that compounds are there to make order compounds are made there in order to make color for petrol, and certain compounds we are adding out that is called as anti-knocking agent. So in case of petrol, I am aware of 3 compounds we have to add more. Number 1 for color, number 2 for odor, and number 3 that is called as anti-knocking agent, so that petrol engine works smoothly. It will not make loud sound. Initially some compound was used that is containing lead as anti-knocking agent, and that's why whatever the effluent gases, they were having some presence of lead from vehicle. Now this is changed to some different compound, and then it is not giving lead as effluent one. Getting idea? What is your role? Again, you are aware now what we have to do. Which compound is used in petrol to make color, which compound is used in petrol to make odor, and which is the name of compound which was used earlier as anti-knocking agent containing lead, and now it is replaced by dash dash compound, so that unleaded petrol is there. 4 names you have to find out, and after finding out names you have to give in comment that these names we have searched out and I got this type of names. Otherwise, in next lecture, obviously it's our role to give you name, but my idea is there, first you have to find out these names.